Alright, so I want to show you how you can use a u-substitution in conjunction with definite integrals to solve these problems a little more easily. So first we're trying to evaluate the definite integral from minus natural log of 3 to 0 of e to the x divided by 1 plus e to the 2x dx. And so as I think about my u-substitution, the first thing I want to remember is that something that looks like e to the 2x is the same thing as e to the x all squared. So that's going to kind of inform maybe my u-substitution. So I'm going to go with maybe u is equal to 1 plus, sorry, let me do this. Erase that. I'm going to let u be equal to e to the x. Then, of course, du is e to the x dx. And I'm going to try another color here just so we can keep up. So du is e to the x dx. Alright, so when we do that, okay, that looks good because here's du, e to the x dx. And then this portion down here, I'm going to just rewrite it in red, is really the same thing as 1 plus e to the x, and then that's squared. So if I were to rewrite just my integral, the integrand portion of the integral, I'm going to have the integral from well, the limits I have to figure out because these limits up here are really for x's, so I'm going to have to change those limits. But my integrand is going to look like du on the top, because that is e to the x dx, and then divided by one plus u squared, because 1 plus u squared is the same thing as 1 plus e to the x quantity squared. So this is the integral that I have to solve now. And so the only thing that I need to change so that I can go ahead and finish this up is that, as I mentioned before, the limits up at the top were for x. But I have a relationship now between x and u, namely that u is equal to e to the x. So when x is equal to 0, u is equal to e to the 0 or 1. And when x is equal to minus the natural log of 3, u is equal to, let's see, I'll rewrite that one step so you can see this. Of course, minus the natural log of 3 is the same thing as the natural log of 3 to the minus 1. And because of the inverse relationship of e to the x and the natural log, then we know that u is equal to e to the natural log of 3 to the minus 1, which is 3 to the minus 1, or 1/3. So we know now that when u is equal to, x is equal to 0, u is equal to 1. And when x is equal to minus ln of 3, u is equal to 1/3. So I think I'm ready to rewrite my integral now. So I have the integral, let me just go back and check those again. I'm going from 1/3 to 1, so 1/3 is the lower limit, to 1 of 1 over 1 plus u squared du. So now if I know the antiderivative of 1 over 1 plus u squared, I'm in good shape. And if you remember, that's going to be tangent inverse. So that means that this is equal to the tangent inverse of u, and I have to evaluate that between plus 1/3 to 1. So this is going to be equal to tangent inverse of 1 minus tangent inverse of 1/3. So for all intents and purposes, I'm done with the definite integral. To actually evaluate this, I probably need to recall a few things from my unit circle, and also that tangent inverse is an angle, and that angle is always in between. So this angle that we're talking about here, let's say theta, is always in between minus pi over 2 to pi over 2, endpoints not included. So tangent inverse of 1, that looks like pi over 4. Tangent inverse of 1/3, that looks like something from my 30, 60, 90 triangle. So let me draw that just so I can recall here. So if this angle is theta, this side is root 3 over 2, this side is 1/2, and this side over here is 1. And actually I'm calling it theta, but I know what that is. This side right here, that angle down there, of course, would be pi over 6, and this angle up here is the 60 degrees, so that's pi over 3. So now just figuring out which one of them gives me its tangent of 1/3. So that's just a relationship of root 3 over 2 Okay, so I was thinking about a little correction here. Tangent inverse of 1/3 is not from any particular triangle. So we're going to get that out of there because I was thinking about 1 over root 3, which is different. So tangent inverse of 1/3 is an inverse tangent that I would have to use my calculator to evaluate. So I can just go ahead and write this as this is equal to, I know the tangent inverse of 1 is pi over 4. The tangent inverse of 1/3 is just exactly the tangent inverse of 1/3. And there we have our solution.